Hello, seniors. Hope you guys are doing all right. I showed one of these videos to my husband, and he said I am way too close to the screen. So I am backing up a little bit, and we are going to keep moving on with this stuff. So we're still talking 68, 95, 99, 7 rule. Let's try a couple of these. I'm going to try the evens. You do the odds. Do the evens with me and do the odds. But I want to warm up with one of these ones. So here's a picture I like a lot because it has everything we've been talking about. It has that 68, 95, 99, 7 rule, and it shows you how those percentages break down below. So let's just run through and answer some of these questions. Let's see, below 60, so my number's right there, this would be a normal distribution. It appears that this is a normal distribution with a mean of 60 and a standard deviation of 5. So what percent are below 60? 60 is the mean, so it's also the median because it's symmetric. And yeah, below average would be 50%. What percent are between 50 and 70? That's all of these guys between 50 and 70. So you can look at it like between 50 and 70 is 95%. That also means within 2 standard deviations of the mean. What percent are between 60 and 65? Whoa, Costco. Between 60 and 65, that's from here to here. The percentage between 60 and 65 is 34%. What percentage is greater than 65? Greater than 65. That's everything from here on up. So you could add up all of these percentages. Also, I always said the teeny tiny tails have 0.15% in them. That's not on this chart. And I know it's 0.15 because I've got 99.7 here, so I have a total of 3 in both tails, so 0.15 there. Greater than 65%, the answer to that would be 16. These numbers keep popping up. 68, 95, 99.7. 16%, 34%, they keep popping up. Okay, good enough on that. Let's get to the ones we came here to do. Number 2, the shelf life of a particular dairy product is normally distributed with a mean 12 and a standard deviation 3. As soon as I read that, I write this. Mean 12, standard deviation 3. I'm going to draw myself a little picture here. It's taken me a long time to get good at drawing these normal curves. Good luck at drawing them. It is not easy. Okay, the mean is 12, and so up 1, 2, and 3 standard deviations, down 1, 2, and 3 standard deviations. So I'm going to add 3, add 3, add 3, subtract 3, subtract 3, subtract 3. About what percent are between 9 and 15? So that's from here to here. 9 and 15 are 1 standard deviation away. That's 68%. 60%, 8% of all dairy products last between 9 and 15 days. Okay, problem number B. About what percent lasts between 12 and 15 days? Between 12 and 15 days. That would go from here to here, and that's 34%. Okay, because I've got that middle 68. Okay, about what percent lasts 6 days or less? 6 days or less. That would be right here. That's one of the tails. I would know that from here to here is 95. Within 2 standard deviations is 95. So I have a total of 5% in each of the tails. In other words, this tail right here has 2.5%. 2.5% of the products last 6 days or less. About what percent lasts 15 days or more? That's this one right here. That's this tail. Remember, I've got the tail, the tiny tail, and the teeny tiny tail. This tail is 16%. This tail, 2.5%. And the teeny tiny tail, more than 3 standard deviations away, 0.15%. Okay, that was number 2. Number 4. On a recent math test, the mean score was 75 and the standard deviation was 5. As soon as I read that, normally distributed, mean score, standard deviation. Okay, Mike got an 85. What percentile does he fall in? We did this last time. This is a review for us. Let's see. Well, no, we could do it this way. I know that he is 2 standard deviations above the mean. He is 2 standard deviations above the mean. I could draw the picture like this. This is 75, 1, 2, up to 85. 2 standard deviations above the mean. Even if I look back at this picture right here, 2 standard deviations above the mean, 2.5%. Two and a half percent are bigger than it, which means 97.5% are less than him, which means he's in the 98th percentile. He's in the 98th percentile. He did really well. He did better than roughly 98% of his peers. Okay, number 6. The speeds of cars on the highway have a mean and a standard deviation. They have a mean 95 and a standard deviation 5. What percent of cars averaged less than 85? What percent of cars averaged less than 85? I'm going to draw a little, well, I could draw a little picture to go with it. But it is conveniently 2 standard deviations less. And I know that there are 2.5% in that little tail, 2 standard deviations to the left. If the police stopped cars that were going more than 105 kilometers per hour, how many, ooh, this one's a little different, how many cars would they stop if there were 8,000 cars? So they're stopping cars that are 3 standard deviations above the mean. Because I start at 95, I go up 1, 2, 3, 100, 105. Oh no, I go up 2 standard deviations. I go up 2 standard deviations, which means they are stopping 2.5% of the cars. So 2.5% of the 8,000 cars gives me 200 cars. They are stopping 200 cars. Okay, number 8. The grading scale is set up for 1,000 students' test scores. It's assumed that they are normally distributed with a mean and a standard deviation. Mean 75, standard deviation 15. How many students will have scores between 45 and 75? I draw my little picture. Mean 75, and it goes up 1, 2, 3 standard deviations right, 1, 2, 3 standard deviations left. So 90, 105, 120, 60, 45, 30. How many scores are between 45 and 70? Between 45 and 75. Okay, that would be, there's 50% to the left of 75, and there's 2.5% in this blank part of the tail. 50% minus 2.5% leaves me with 47.5%. There are 47.5% of the 1,000 students, which is 450 students. 475 students. If 60 is the lowest passing score, how many students are expected to pass the test? How many students are expected to pass the test? I'm going to draw another little curve over here. It was 75, and this is 60. 60 is 1 standard deviation below the mean. All of these students are going to pass the test. I know that there's 16% in this tail. Which means 100% minus 16% leaves you with 84% in this part. I expect 84% of them to pass. 84% of 1,000 students are going to pass. In other words, 840 students are going to pass. Okay. All right, guys. I did half of them. I know it's not easy stuff. See what you can do. And